When I'm talking about the case of your gaseous state, the very first one you talk about the case of your Boyle's law. The volume of a given mass of gas is inversely proportional to the pressure. Is inversely proportional to pressure. P is inversely proportional to volume. Right? So here in this case, pulling up increases the volume and decreases the pressure. Piston ni when you are pulling upwards, piston మనం పైకి లాగుతున్నప్పుడు when you are pulling it in the upward direction, volume అనేది ఇంక్రీజ్ అవుతుంది. వాల్యూమ్ ఇంక్రీజ్ అయింది కాబట్టి ప్రెషర్ అనేది ఆటోమేటిక్గా డిక్రీజ్ అవుతుంది. లేదా in this particular case, when you are pushing the piston inside, when you are pushing the piston inside, volume is decreasing but pressure is increasing. Right? Or PV equal to constant or P1 V1 equal to P2 V2 అంటాం. At the same time, right, at constant temperature, pressure of a gas is directly proportional to density. Pressure of a gas is directly proportional to density. P is proportional to D or P by D equal to constant or P by D equal to constant. Right? This is the main case. Next one, Charles' law. According to Charles' law, at constant pressure, pressure has to be maintained constant. At constant pressure, volume of a fixed mass of gas is directly proportional to absolute temperature. Volume and temperature both are directly proportional, or else you can write V by T equal to constant. V by T equal to constant. At the same time, the lowest temperature at which gases are supposed to occupy zero volume is called absolute zero temperature. Now, absolute zero temperature ante enti? A temperature of 0 Kelvin లేదా -273 degrees centigrade ని మనము absolute zero temperature అంటాం, లేదా absolute temperature అని అంటాం. At this particular temperature, the volume occupied by gases is assumed to be equal to 0, is considered to be equal to 0 అంటాం. Right? So, V by T equal to K, or else you can even write V1 by T1 equal to V2 by T2. Then, Gay-Lussac's law. According to this one, at constant volume, pressure of a fixed amount of gas varies directly with temperature. Pressure is directly proportional to temperature. P by T equal to constant, or else P1 by T1 equal to P2 by T2. P1 by T1 equal to P2 by T2. So here you can see, as the pressure is increased, the movement of the gas molecules keep on increasing. Why? Because their energy is increasing. Temperature increase అవుతుంది కాబట్టి వాటి యొక్క ఎనర్జీ కూడా ఇంక్రీజ్ అవుతుంది. Right? So P1 by T1 equal to P2 by T2. And then the case of your Graham's law of diffusion. So as per the case of your Graham's law of diffusion, the rate of diffusion of a gas is inversely proportional to square root of its density. సో ఒక పర్టికులర్ గ్యాస్ ఎంత స్పీడ్గా డిఫ్యూజ్ అవుతుంది, ఇట్ ఈస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు, ఇట్స్ ఇన్వర్స్లీ ప్రపోర్షనల్ టు ద స్క్వేర్ రూట్ ఆఫ్ ఇట్స్ డెన్సిటీ. R1 by R2 equal to under root D2 by D1. R is proportional to 1 by root D, or else you can even write R1 by R2 equal to under root D2 by D1 antam. Right? So what is this particular ideal gas equation? From the case of your Boyle's law, V is proportional to 1 by P. From Charles' law, V proportional to T. From Avogadro's law, V is proportional to N. When you're combining all the three, we get V proportional to NT by P, or else V equal to R into NT by P, or else NTR by P, or PV equal to NRT. This is what you call it as ideal gas equation. Where R is known as universal gas constant. And the value of R is 0.0821 liter atmosphere mole inverse Kelvin inverse లేదా 8.314 joule mole inverse Kelvin inverse, right? 8.314 joule mole inverse Kelvin inverse లేదా 0.0821 liter atmosphere mole inverse Kelvin inverse, right? So this is about the case of your gaseous state. As for the case of your Boyle's law, P is proportional to 1 by V. Charles law, V is proportional to T. Gay-Lussac's law, P is proportional to T. Avogadro's law, V proportional to N. And as for the case of your Graham's law of diffusion, R is proportional to 1 by root D. So when you're combining వీటిలో కొన్ని ఈక్వేషన్స్ కంబైన్ చేస్తున్నప్పుడు ఏవవి Boyle's law, Charles law, Avogadro's law. When you're combining all these three, we get one particular thing which are calling it as ideal gas equation, that is PV equal to nRT. Right? So based on these things, we'll try to do some problems based on, moving on to the very first problem. A given mass of gas is allowed to expand from a volume of 250 ml. So initial volume, it is given as 250 ml to 500 ml. So V2 is given as 500 ml. The pressure of the gas after expansion. And the gas is undergoing certain amount of expansion. So after expansion, P2 antam. P2 is equal to 3 atmospheres. What was the pressure of the gas before expansion? So before expansion, in the sense P1 value equal to how much? Right? Now here in this particular case, only pressure and volume ఈ రెండిటి గురించి మాత్రమే కన్సిడర్ చేయబడుతుంది. So it means that here in this particular case, temperature of the system constant గా ఉంది. Temperature is constant. So temperature is constant in the sense we are talking about the case of your Boyle's law. So Boyle's law, pressure and volume both are inversely proportional. So Boyle's law base చేసుకుంటే, based on that one, P1 V1 equal to P2 V2. So here in this case, we need to find the value of P1. So P1 equals to P2 V2 divided by V1. P2 value is 3, V2 value is 500. At the same time, V1 value is equal to 250. So it means that P1 equal to 6 atmospheres. 6 atmospheres. This is the answer. Now, in case in the examination, if the question comes like this, it's very simple. So question choose manam instead of doing all this particular thing, direct ga manam answer raseyochu. We know that pressure and volume both are inversely proportional. Pressure increase avute, a volume anedi automatically decrease avutundi. So here in this particular case, volume is getting doubled. Volume double avutundi annappudu pressure anedi it should reduce to half. Volume is getting doubled, so pressure anedi half avvali. So half the pressure 3 atmosphere అయినప్పుడు అంటే 50% of the pressure equal to 3 atmosphere అయితే 100% ఏమవుతుంది, right? Nothing but 3 into 2, 6 atmospheres. Volume is getting doubled, so pressure అనేది half అవ్వాలి. So half the pressure, half the value of P is nothing but 3 అన్నప్పుడు complete value of P, 100% P value ఎంత అవుతుంది? Nothing but 6 atmospheres, double this particular value. Right? Then moving on to the next question. A gas is enclosed in a cylinder under STP conditions. Now always remember, whenever you find this word STP conditions in a word కనిపించినప్పుడు, temperature always take it as 0 degrees centigrade, or else you take this one as equal to 273 Kelvin antam. 0 degrees centigrade or else 273 Kelvin. Right? At the same time, at what temperature the volume of the gas is reduced to half its volume? So whenever this word is found, STP, take the value of temperature to be 273 Kelvin. At the same time, pressure is supposed to be 1 atmosphere. Rendu kuda basic conditions ikkada. STP conditions దగ్గర temperature and pressure values will be always maintained as at STP conditions, always maintained as temperature 0 degrees centigrade, pressure to be 1 atmosphere. Now here in this particular case, volume is reduced to half of the original volume అన్నాడు. అంటే V1 ఈక్వల్ టు V అనుకుంటే దెన్ V2 ఎంత ఉంది? V2 ఈక్వల్ టు V1 by 2 అంటున్నాడు. ద ఫైనల్ వాల్యూమ్ అనేది ఒరిజినల్ వాల్యూమ్కి సగం అవుతుంది. ఆర్ ఎల్స్ యూ కెన్ ఈవెన్ రైట్ దిస్ వన్ యాజ్ V by 2 అని రాస్తాం. వై? బికాస్ వీఆర్ అస్యూమింగ్ దట్ V1 ఈజ్ ఈక్వల్ టు V. సో V2 ఈక్వల్ టు V by 2. సో we know that as per the case of your Charles law, volume and temperature both are directly proportional. So volume అనేది డబుల్ అవుతే టెంపరేచర్ కూడా డబుల్ అవ్వాలి. వాల్యూమ్ అనేది హాఫ్ అయినప్పుడు టెంపరేచర్ కూడా హాఫ్ అవ్వాలి. సో హియర్ వాల్యూమ్ ఈజ్ గెటింగ్ రెడ్యూస్ టు హాఫ్. సో వాల్యూమ్ హాఫ్ అయినప్పుడు టెంపరేచర్ ఏమవ్వాలి? టెంపరేచర్ మస్ట్ ఆల్సో బికమ్ హాఫ్ ఆఫ్ ఇట్, విచ్ మీన్స్ 273 Kelvin by 2, nothing but 136.5 Kelvin. ఇది మనకు రావాల్సిన ఆన్సర్. ఆర్ ఎల్స్ వెన్ యూ గో ఇట్ బై ఫార్ములా వైస్, సో యాజ్ పర్ ద కేస్ ఆఫ్ యువర్ చార్లెస్ లా, V is proportional to T కాబట్టి V1 by T1 equal to V2 by T2. So we are supposed to calculate the value of T2 calculate చేయాలి. So T2 equal to V2 into T1 divided by V1. What is the value of V2? So T2 equal to V by 2 into, what is the value of T1? T1 is 273 Kelvin divided by, what is the value of V1? V1 is nothing but V. So V and V will get cancelled. 273 by 2, this is nothing but 136.5 Kelvin. 136.5 Kelvin. Seems only on one simple relation, V proportional to T. So volume అనేది right, sorry, here volume becoming half. So volume అనేది half అయింది కాబట్టి temperature must become half. That is the reason why you are writing it as 136.5 Kelvin. Right? Then moving on to the next question. A gas is contained in a cylinder at STP conditions. Again the same thing. At what temperature volume is doubled? So if T equal to 273 Kelvin, right, V1 equal to V and V2 equal to 2V. So volume double అవుతుంది కాబట్టి temperature must also become double. That is the reason why T2 will become equal to 546 Kelvin. 546 Kelvin. Now these are the two previous questions. Right? Earlier these two questions were asked in the examination, so I have just repeated these questions. Next one. A gas at minus 10 degrees centigrade. So one thing, whenever temperature is given in centigrade, first దాన్ని Kelvin లో convert చేసుకోవాలి, because Kelvin is an SI unit కాబట్టి. So here T1 equal to minus 10 degrees centigrade, converting this one to Kelvin. So this is 273 plus minus 10, nothing but 263 Kelvin. 263 Kelvin is heated at constant volume. Volume is maintained constant. Volume constant ga annappudu, this is nothing but your Gay-Lussac's law. Pressure is directly proportional to temperature. Pressure is directly proportional to temperature. Right? So if pressure is 75 centimeters, P1 equal to 75 centimeters of mercury. If pressure is 75 centimeters of mercury, small correction, pressure is 75 centimeters of mercury at 27 degrees centigrade, small correction, at 27 degrees centigrade, find the initial volume. So here we are supposed to calculate the initial, pressure, find the initial pressure, small correction. Right, here you have got two corrections. One is 27 degrees centigrade and the other one is initial pressure. So P2 is equal to 75 centimeters of mercury At what temperature? At a temperature of 27 degrees centigrade. So converting this one to Kelvin, 273 plus 27, that equals to 300 Kelvin. Right. Then find the initial pressure. P1 equal to how much? So as per Gay-Lussac's law, P1 by T1 equals to P1 by T1 equals to P2 by T2. P1 by T1 equals to P2 by T2. Or else P1 equals to P2 into T1 by T2. P2 into T1 by T2. That is as per the case of your Gay-Lussac's law. So finding what the value of P1. So P1 equals to, P2 value is 75. Right. So here P2 value is 75 into T1 value is 263 divided by T2 value is 300. 75 1 time, 75 4 times. Right. So P1 equals to 263 by 4. 4 6 times 24. 23 is left. 4 5s 20. 65.7. Right. Something around 65.7 centimeters of mercury. 65.7 centimeters of mercury. Right. So this is the final answer for that one. The next question. Find the pressure of 14 grams of nitrogen gas occupying 2 liter volume at 27 degrees centigrade. Occupying 2 liter volume at 27 degrees centigrade. So here volume is given as 2 liters. Temperature 27 degrees centigrade. So 27 degrees centigrade, or else you can even write this one as 273 plus 27, that is equal to 300 Kelvin. That's equal to 300 Kelvin. Then weight is given as 14 grams of nitrogen. So here we are supposed to calculate the value of P. So ideal gas equation base cheskunnappudu PV equal to nRT anta. But what is N? N is nothing but number of moles. So number of moles formula ఏంటి? Number of moles equal to weight by molecular weight anta. Number of moles equal to weight by molecular weight. So we need to find the value of P. So P equal to N into RT divided by V. Right. So what is the value of N? Number of moles and weight by molecular weight. So 14 grams of nitrogen divided by molecular weight of nitrogen is 28 into what is the value of R? R is given as, right, 2 liters అన్నట్టు కాబట్టి here we take in terms of liters తీసుకుందాం. So you have got two different values, 8.314 joule mole inverse Kelvin inverse ఒకటి ఉంది, ఇంకో యూనిట్ 0.0821 లీటర్ atmosphere mole inverse Kelvin inverse. This is one more unit. So since the volume is given in terms of liters, we are taking it in terms of liters, that is 0.0821 into temperature is how much? 300. Right? Divided by V. What is the value of V? 1 by 2. 1 by 2. So here 14 1 times, 14 2 times. So this is 150 times and this is 75. So you get this one as 0.0821 into 75. So the pressure that is occupied by this particular gas equals to 0.0821 into 75 centimeters of mercury. Whatever is the final answer here. 0.0821 into 75 centimeters of mercury. Whatever is the final answer. Right? Then the next question. Find the volume of 1 decimole of oxygen. So decimole. So N value is given to be 0.1. Deci in the sense 0.1. Centi 10 power minus 2. Deci is 10 power minus 1. Centi is 10 power minus 2. Right? So this is 10 power minus 1 in the sense 0.1. So N equal to 0.1 moles. Decimole oxygen at 0 degree centigrade. Temperature equal to 273 Kelvin. Right? And at 2 atmosphere pressure. P equal to 2 atmospheres. Find the volume occupied. So here the same equation PV equal to nRT, or else V equal to N into RT by P. So if you simplify this, V equal to 0.1 into R value, again the same thing, 0.0821 into temperature is 273 divided by 2, since the pressure is 2 atmospheres. So the volume will be 0.1 into 0.0821 into 136.5 liters, whatever is the final answer, right? So please solve this and get the final answer here. So this is the final volume that is occupied by 1 decimole of oxygen at 2 atmospheric pressure and 0 degree centigrade, right? Then moving on to the next question. The rate of diffusion of O3 gas is how many times of sulfur dioxide gas? So this particular question is based on Graham's law of diffusion, wherein Graham's law of diffusion states that rate of diffusion of a gas is inversely proportional to square root of its density, right? Now here diffusion, we need to find out how many times oxygen is diffusing faster when compared to sulfur dioxide gas. For that we need to know the molecular weights of this one. Simple thing, density, molecular weights avasram enti, density equal to mass by volume here. Density equal to mass by volume. Assuming the volume to be constant, based on that particular thing we are taking mass తీసుకుంటున్నాం. Assuming volume to be maintained constant, right? So we are taking the molecular weight into consideration. So the molecular weight of O3 gas, molecular weight of O3 gas. So this is 3 into 16, that is 48. 3 into 16. Oxygen molecular weight is 16, but O3 kabatti you are taking it as 48. Alage sulfur dioxide, molecular weight of SO2. Sulfur atomic number is 16, molecular weight is 32, plus 2 into 16, that is equal to 64. So rate of diffusion of O3 gas, rate of sulfur dioxide gas inversely proportional to their molecular weights. So first పైన మనం ఏం రాయాలి, సల్ఫర్ డయాక్సైడ్ రాయాలి. 64 divided by ఆక్సిజన్ ది కింద ఉంటుంది, O3 ది కింద ఉంటుంది, 64 by 48. So 8 8 64, 8 6 times, right? 4 or 2 4 times, and this is 3 times. So this is nothing but root under root 4 is to root 3, or else you can even write 2 is to root 3. 2 is to root 3. So this is the rate of diffusion of those two gases, right? 2 is to root 3 times. So this is about the case of your gaseous state, along with some of the previous problems, right? Thank you. So in the next class, we'll be discussing about the case of your chemical fuels as well as the case of your metallurgy, right? Thank you.